question 12 in the homework is converting from a decimal number that has a decimal value, that has a 0.3, 0.4. You first do the place values to the left, and then you tackle the place values to the right. If I'm going to convert to binary, I want to think about how many halves I have, how many quarters, how many eighths, 2 to the -1, 2 to the -2, 2 to the -4, right? Those are my binary place values. So I take my 0.4 in decimal, and we get to binary by multiplication by 2. So we get 0.8. And we said on Monday that because we've got a 0 here, the first digit, so if I start building my binary number, the first digit to the right, well, it's a 0. This is this digit. All right, then we kept going. We took the 0 out of it. So now we have just the 0.8. We multiply by 2 and we get 1.6. Wonderful. That's a 1. So the next digit to the right is a 1. So taking that 1 away and leaving us with a 0.6 allows us to keep going. 0.6 times 2 is 1.2. That was another 1. 0.2 times 2 is 0.4. And there's another 0. And now there are a couple methods here. So we have 0, 1, 1, 0. So that was what we had done on Monday. Now, is it? Yeah, I did start with the 1 on Monday. We did do 0.4. The question asks us to answer rounded to 4 binary places. So rounded to 4 binary places. The problem with this is that there are a number of different conventions to do that. One of them is to simply truncate, which is what I showed us on Monday. I said, we want to go to 4 places. I'm going to go to the first 4 and then stop. That's often going to be the computer application, especially because the way a computer handles decimals, they don't actually look like this. You don't have binary places. You're going to use a different system. So some of this becomes moot. But because of the language of this question, rounding, and its context in this math module course, is that we have to round as we normally would if we were just tackling a decimal number. So this was my first mistake. So yes, we went to 4. That's great. But then I should have kept going because I want to know, what is this next value? Because what that next value is will tell me how to round the 4th. The same way that if I have a number 0.125637, I write I have some number, my calculator tells me this, but the question wanted me to round to the nearest 100th, right? If this is a normal decimal number, well, then I look at the 1 to the right, and if it's 5 or greater, I round up, right? That's just rounding in decimal. We always write down more numbers than we need. So I didn't do that. So let's do that now. So if I simply continue on, this was our 0.4. Let's keep going. 0.4. Let's multiply that by 2 as well. And we get 0.8. So our 5th number to the right of the decimal is also a 0. Our 5th number to the right of the decimal is also a 0. So that means we round down. So round down. So the answer really is, so 0.4 really is in binary 0.0110. We rounded down to 0 instead of rounding up to 1. So I did give you the correct answer, but I got lucky. If this digit here had been a 1, the final answer would have been 0.0111. We would have had to round this 0 up to a 1. Where we notice this becoming a problem is if you try starting with 0.3. So I got lucky. Let's try the same thing again. So I'm taking 0.3 and I want to convert that to binary. So I get 0.3. I multiply that by 2. I get 0.6. The first number to the right of the binary point is going to be a 0. And then I take 0.6 and I multiply it by 2 and I get 1.2. The next value over is a 1. Now I take the 0.2, multiply by 2, and I get 0.4. That's a 0. We're almost at 4, so we're getting there. 0.4 times 8. 0.4 times 8. I just completely lost my train of thought. Why am I multiplying by 8 is a very good question at this point. I threw the 8 in because my brain is already at the answer. 0.4 times 2 is 0.8. So the fourth number looks like it should also be a 0. So those are 4 binary places. So right now we are at 0.0100. But, so that's the fourth place. What I didn't do prior was investigate this fifth place. So if I now take this 0.8 and I multiply by 2, I get 1.6. So the fifth digit was a 1. The fifth digit was a 1. And even though the answer was supposed to have only 4 digits, I need to see what that digit would be. Because it's greater than half, right? In base 10, it's 5 or greater. So in base 2, it's going to be 1 or greater. That means, therefore, to get to the final answer, therefore, we're going to round up. And we can say that 0.3 in base 10 is equal to 0.0101 in base 2. That's how we're going to do these questions. There are as many rounding conventions as there are people potentially, maybe not quite that many. There are lots of different rounding conventions, and that's true in decimal as well. That's absolutely true in decimal as well. So the rounding convention we're going to use is, if you want the answer to 4 binary places, find 5 to allow you to round the 4th place. So this will give us the correct answer that my lab was looking for. And so my error was that I truncated. I did not go to the 5th decimal place. In fact, that was just my first error. And then I got carried away. And this one dawned on me based on 2 pieces of information. The way this question continues, this is the first question. The part A said round to so many binary points, make sure you're converting to binary. And then the second part of that question asks us to take the same value, 0.4 or 0.3, and go to octal and then to hex. It is absolutely true that if your number in binary is given as 0.0100, or whatever that number happens to be. Let's actually use one of these two. So let's use the one down here. So this did end up being 0.0101. So let's use that. If this is your binary number and that's given, how do we convert that to octal? Well, to convert it to octal, we know how to do this. Octal is groupings of 3. So we would pad our number and add 2 and just convert to the octal number. So this would be 2, this is a 4, and we have 0.24. Now, that's fine. This is true. This is internally consistent. So this is the binary, that's the octal. But I made up those 2 zeros. I padded our number. We know what the number is supposed to be because we can start with 0.3 and make sure that we have enough digits in our binary answer. So even though part A said, I want you to round to 4 decimal places, part B asked for an octal number, sorry, to 4 binary places. Part B asked for an octal number that was 2 octal places. So I can either start from the 0.3 in base 10 and convert that to octal, or I can start from the binary and convert that to octal. But if I'm starting from the binary, I better know enough of those binary places. So we can't pad it. We can't pad it. We have to know what those are. How do we know what they are? We just keep going. Keep going, multiplying by 2, and continue to build that binary number. So my brain stopped working. I just said, here's a binary number. Let's start there. I was very blinkered and said, let's take that binary number as is and convert it to octal. But that's not what the question is. The question says, take this decimal number and find all of the others. So that was the other error that I made in class the other day. So this isn't going to work for us. We can't do this. I'm going to leave it here. One easy way that's been suggested here is because these numbers are quite long, right? I'm just truncating them here, but there are a lot of values here. This number is as high as 40, 50, 60,000. It takes a long time to convert that to binary. So we convert to binary by divisions by 2. You could choose instead to go straight to octal. So looking for dividing by 8, looking for groups of 8, or straight to hex. So you can move in any direction you like. You don't have to do it in any particular order. You just have to be a little bit more careful than I was. The other thing that works nicely here is if I'm starting with 0.3, and I'd like to know what that is in octal, and I'm worried about the decimal place, that 0.3. Well, how did we deal with it in binary? We simply multiplied by the base 2. So how will we deal with it to go to octal? Well, we're going to multiply by 8. So 0.3 times 8 is 2.4. So the first number to the right of the octal point will be 2. What's left over? We have 0.4 left over. 0.4 times 8 is 3.2. So the next number to the right of the octal place, this one was 2, the next one will be a 3. And just to make sure we know that we're absolutely certain that this is in fact a 3 and doesn't round up to 4. And here the instruction was 2 octal places. That's the instruction, 2 octal places. I'm going to keep going by just 1 and say that this is 0.2 times 8 is 1.6. So the last number would have been a 1. So we have 0.231. If it's 4 or greater, we would be rounding the 3 up to a 4. But because it's only a 1, we're going to round down to 3. So the final answer is 0.23 in base 8.